Hey everybody, today we're going to be going over the review for Unit 7. So yeah, let's get right to it. So the first part of this review is all about the proportions. So we're going to cross multiply and solve here. So 7 times 8 is 56, 2 times x is 2x. So 2x equals 56. We're then going to divide by our coefficient, which is 2. And half of 56 is 28. Okay. Here we're going to do the same thing. We're going to go ahead and cross multiply. So 4 parentheses, and you could simplify that to 1/2. I'm not going to do that though. Equals 2 times 10 is 20. We're going to go ahead and distribute that 4, and again you could divide by 4 if you wanted to. It doesn't really matter. Equals 20. Subtract 20 from both sides. We're going to get 4x equals 0. Divide by our coefficient, and x will equal 0. Oh, what's happening here? There we go. Sorry about that. X equals 0. Okay. We're going to cross multiply here. So 10 times k is 10k. And 5 parentheses k minus 3. We're going to distribute that 5. So we're going to have 10k equals 5k minus 15. We're going to then subtract 5k from both. That's a crappy looking 15. Hold on. There we go. We're going to subtract 5k from both sides. So 5k equals negative 15. Divide by 5. K equals negative 3. We're going to then distribute. We're going to cross multiply here. Scroll up a little bit. Okay, so 7 parentheses r minus 8, and 9 parentheses r minus 5. And then we distribute. 7 times r is 7r. 7 times negative 8 is negative 56. 9 times r is 9r. 9 times negative 5 is negative 45. Okay, we're going to get the r's on the same side. So we're going to subtract 7r. We're going to run out of room here, so we're going to have to scroll over a bit. These cancel. Let's separate this a little bit. So negative 56 equals 2r minus 45. I'm going to add 45 to both sides. And that's going to give us, let's make sure I didn't screw this up here. Hold on. So 7 times r minus 8, we get that. 9 times r minus 5, you got to distribute. 7r, negative 56, 9r, yeah, this is right. Negative 7r, yep, 2r, add 45. Okay, so this is going to be negative 11, I believe. Yep, equals 2r, divide by 2. And r will be equal to negative 5.5. Okay, let's go over here. We're going to cross multiply. Oops. X times 5 is 5x. 9 times 4 is 36. Divide by 5, and we will get x equals 7 1/5, or 7 2/10. Okay, cross multiply here. 5 parentheses k minus 8, and then 7 times 10 is 70. We're going to distribute. 5 times k is 5k. 5 times negative 8 is negative 40. 70. We're going to add 40 to both sides. And 5k will equal 110. We're going to divide by 5. Yeah. And then k will equal, oh, what is that, 22? Yeah, 22. There you go. Zoom in a little more here. So we're going to cross multiply here. 3 times x is 3x. 8 parentheses x plus 3. We're going to distribute that 8. 3x equals 8x minus 24. Okay, we're going to subtract 8x from both sides. So we have negative 5x equals negative 24. Divide both sides by negative 5. X equals positive 4 4/5, or 4 8/10. Okay, we're then going to do cross multiplication. We'll do 6 parentheses r minus 1 equals 8 parentheses r minus 8. We're going to distribute these. 6r minus 6 equals 8r minus 64. Subtract 6r from both sides. So we have negative 6 equals 2r minus 64. I'm going to rewrite that over here so we have more room. Negative 6 equals 2r minus 64. We're then going to add 64 to both sides. Let's see, it's going to be 58. Yep, 58 equals 2r. Divide by 2. And r equals 29. Okay, so those are pretty straightforward. I think I'm confident that you guys are pretty comfortable with the proportions. All right. Let's see. The length of a model train is 18 inches. The scale model of the train is 48 feet long. Find the scale factor. Okay, so you got to be careful for this. You have to be careful because this is in inches and this is in feet. And it's really easy just to say, 18 over 48. This also doesn't tell us, it doesn't ask us, well, it doesn't clarify which scale factor it wants, if it wants small to big or big to small. So we can interpret that either way. We're going to go small to big. So the small number will be, the smaller version will be, sorry, the model will be on the top number. And our actual value will be on the bottom. Okay. And we have to convert these to be the same unit of measurement. So this is inches, this is feet. Be careful for that. Don't be caught by that. That is something I've seen on many a standardized test. Okay, MCAS, SAT, ACT, whatever, PSAT. That's like an old trick in the book. When I was a kid, they did that. So we're going to convert this to inches. We're going to keep it all in inches. So how many inches in a foot? 12. So we're going to go 48. Oops, get rid of that. 48 times 12, which is 576. So we're going to change this to 576 inches. Okay, and we're going to just go small over big. So the model is 18 inches long. The actual train is 576 inches long, and that's our scale. That's our scale factor. Now, can we simplify that? Let's see. Is 576 divisible by 18? It is. So we're just going to have 1 over 32. We divide the top and bottom by 18, we're going to get 130. So it's a 132 scale. Now that's probably the answer they want, because when you look at a scale factor for like a model, that's typically what they say, is a 1 over whatever, 1/25th, 1/30th, whatever. But yeah, I mean, I think you can make the argument that you get 32 over 1 and you could win that argument. All right, so this is basically a bunch of stuff we did, but all in word problem form. All right, an artist in Portland, Oregon makes bronze sculptures of dogs. That's weird. The ratio of the height of a sculpture to the actual height is 2 to 3. The height of the sculpture is 2014. Okay, so they give us the scale factor. So the model, like sculpture would be 2, the actual would be 3. Okay. If the height of the sculpture is 14, what's the height of the dog? All right, so we're going to have sculpture, sculpt over actual. So 2 over 3 equals, and then the sculpture is 14. What's the actual height of the dog? Okay, so making the proportions is actually really the only tricky part here. We're going to cross multiply and solve. We're going to get 2x equals, what's 3 times 14? 2 times 14 is 28, 38, 42. Does that sound right? Let's double check. It never hurts to check, guys. 3 times 14. Yep, 42. These are useful to have around. Divide by 2. And x will be equal to, now make sure you don't forget your units measurement here, 21 inches. Okay. The span of the Benjamin Franklin Bridge in Philadelphia, Pennsylvania is 1,750 feet. A model of the bridge has a span of 42 inches. What's the scale factor of the model to the span of the actual? Okay, so this one's more specific. So it's model to actual. So this is going to be small over big. Model to actual. And be careful, again, they try to mess with the units of measurement. So the model is 42 inches. The actual is 1,750 feet. We're going to convert that to inches. So it's just easier to do it that way. So 1,750 times 12, because it's 12 inches in a foot. So 21,000 inches. That's a lot of inches. All right, so 42 inches is the model. 21,000 is going to be the actual. Can we simplify that? Sure we can. They're both divisible by 2. So 21 over, let's divide that by 2. 10,500. And this is divisible by both 7 and 3. Let's see if this is divisible by 21. I don't think it is. Let's just double check. It is. Wow, it is. Okay, so it's 1, so that'd be 500. So this would be 1 over 500. Okay, I didn't expect that. When a 9-foot tall shed casts a 5'3" shadow, a house casts 28-foot shadow. Okay, so we're gonna draw a picture here. So we have a garden shed. There's the garden shed. Pretty sweet, right? And this is 9 feet tall. And the shadow is 5 feet 3 inches. That's the shadow. Okay. Here's the sun. Yay, sun. Okay. And then we have a house. Okay. Cast a 28-foot shadow. 28-foot shadow. 28 feet. We don't know what the height is. So we're going to set that up as a proportion. We're going to have height over shadow. Height over shadow. And this is going to involve some conversion because we have feet in inches. We're just going to do everything in inches. Makes it easier. I think it does at least. So let's do the shed first. So we're going to convert that to inches. So 9 times 12. 9 times 12 is going to be 108. So 108 inches, that's the height of the shed in inches. And then 5'3", so 5 times 12 is 60, plus 3 is 63. So it's 108 over 63, and that equals, and then the height, we don't know what that is. The height of the house, we're not sure. 28 feet, let's simplify that. Let's convert that. 28 times 12, 336. And we're just going to cross multiply this. You're going to get some weird numbers, but that's okay. So 336 times 108 is that awful looking number. So first we have 63x equals 36,288. And divide that by 63. 576. So the house is 576 inches. Let's see if that's divisible by 12. Because we can convert it back to feet. It is. So it's 40, either 576 inches or 48 feet high. Doesn't matter. Okay? The hard part with these is just making the proportion. The actual cross multiplication and solving you guys can do pretty easily, but making these takes a little bit of effort here. Of the 112 students in the marching band, 35 are in the drum section. What is the ratio of drummers to other musicians? Okay, so drummers is 35. The other musicians would be whatever is left over, the difference, right? So we're going to go 112 minus 35. And that's going to equal, I'm not going to be that lazy, am I? No, let's just do it, whatever. So 12 minus 5 is 7, 10 is 77. So that's the ratio of drummers to other musicians, because it'd be 77 left over. These are both divisible by 7, so 5 over 11. And that's it. Ratio of the measures of 3 angles of triangle. This is funny, because one of my coworkers, Mr. McCord, you may know him, we were talking about a question just like this the other day. So 3 to 4 to 8, find the measure of each angle. So that's the ratio of the measures of the triangle. So we know that the 3 angles add up to 180 degrees. We don't know what the actual measurement is, but we know their relationships. We're just going to put a variable in. So 3x plus 4x plus 8x equals 180. We're going to solve for x. So 3 plus 4 is 7, 7 plus 8. Oh, I'll be right back. That is something I'm cooking. All right, sorry about that. Had to have a lunch. Some delicious clam chowder. Good stuff. Let's combine these together. So we got 3x plus 4x is 7x. 7x plus 8x is 15x. And by the way, if you haven't tried clam chowder along with some English muffins, I'm going to make that suggestion. It's pretty incredible. They're like perfectly designed to absorb the deliciousness of chowder. Fun fact. All right, here we go. So divide by 15, that's our coefficient. X is going to be equal to 13, I think. Is it 13 or 12? 15, 10. My brain isn't working. Let's see. 180 divided by 15 is 12, yeah. So I thought 12. Okay, cool. Let's see what else we got. Alright, so number 15. The measures of the... So this is a similar problem. The ratio of the measures of the sides of a triangle are 6, 9, 10. The perimeter is 100. Okay, so remember the perimeter is when you add things up, right? So this is actually pretty similar to the previous problem. So these three values along with the variable add up to the perimeter. So 6x plus 9x plus 10x equals the perimeter, which is 100 centimeters. Oh, did they give us... Hold on. Let's go back to the previous problem. Should be 12. Oh, I almost screwed up big time. It's not asking us for the variable, it's asking us for the measure of each angle. Let's go back to that. So we have to plug this in for x and find our missing angles. Good thing we went back. So it's 3 times 12 is 36 degrees. 4 times 12 is 48 degrees. And 8 times 12 is 96 degrees. And those are the three angles. Okay. Good thing we went back there. Alright. So let's add these together. So 9 plus 6 is 15. 15 plus 10 is 25x equals 100. We're going to divide by our coefficient, which is 25. And 100 divided by 25 is 4. I'm going to move this so I don't have to keep leaning. So there we go, that's a little better. X is equal to 4. But we have to find the measures of each side. So we're going to plug this in. So 6 times 4 is 24, and it's going to be, what is it? Centimeters? 24 centimeters is the first one. And then 9 times 4, that's 36 centimeters. And 10 times 4 is 40 centimeters. If the triangle BAT is similar to triangle MAN, determine the segment should be placed. Okay, so, alright, so we have to look at these segments here. So, BT is the first and last. MN is the first and last. So that's what this is. NA is a different color here. NA is the last two. So that's going to be AT. Or TA, doesn't really matter. Okay. Excuse me. Given triangle MVU is similar to triangle MLK, what is the value of x? Alright, let's make sure we know what's going on here. So MV, that's the first two. So the first two are ML. So, oh, blue to red, sorry. So those are going to match up. So we're going to say, alright, so 2x plus 4 over 126. And then VU, which is the last two. And the last two over here should be LK, which they are. Just like that. So we're going to have 26 over 117. We're going to cross multiply and solve here. So 117 parentheses 2x plus 4. You can see where the calculator makes this a lot easier. Unless you want to do all this by hand, but you know how it is. Let's make our lives easier here. 126 times 26, and that'll equal 3,276. Okay. We're going to distribute this 117. These are some weird numbers. I think it's 234, but let's just double check. 117 times 2. Yep, 234. 234x plus, I'm guessing that's 468. Let's see. Hold on. 117 times 4. Yep, 468. Equals 3,276. We're then going to get rid of our constant, which is 468, so subtract 468 from both sides. So we're going to do 3,276 minus 468. That's 2,808. Oh, why am I using that color? Sorry. Equals 234x. divide by our coefficient. And it's going to be 12. Okay, so x is equal to 12, which is D. Okay. Determine if the polygons are similar, show work. Okay, so similar shapes have to have congruent angles and corresponding proportionate sides. So the angles all match up. So we really just have two values to check, 7 over 14 and 8 over 18. So, because we do small over big, small over big. So 7 over 14 and then 8 over 18, are those equal ratios? I don't believe they are, because this is 1/2. And this would be, what, 4/9? So this is just under a half, so no, they're not similar. Okay, let's check this one out. So what is the value of x? And they give us the similarity statement right here. So x is TC. So TC is are the first two letters here. That means they match up with EC. So EC is right here. So we're going to go blue over red. So we're going to 13x minus 3 over 60 equals, and then 36 is CU, which are the last two, which means CD is the last two, which is right here. So we're going to go 36 over 60. I'm going to simplify that. I'm going to divide those both by 6 and make that 6 over 10. Actually, I can go even further, can't I? I can divide those both by 12. So this would be 3 and this would be 5. So yeah. 3 divided 12 is 36, yep, and then 5 times 12 is 60, yep, that's right. Okay, so 13x minus 3 over 60. We're going to cross multiply and solve. So 5 parentheses 13x minus 3 equals 60 times 3, which is 180. We're going to distribute this 5. So what is that? 65x minus 15 equals 180. We're going to add 15 to both sides. So we have 65x equals 195. And we're going to divide by 65. So 195 divided by 65, and that equals 3. So x is equal to 3. There we go. Okay. You can see the importance of the similarity statements. That's essentially how we solve that. All right. Use the figure below. Okay, so write a similarity statement for each of the triangles. So we're going to use the the angle for the first letter. So we're going to go this one here. So we'll go triangle ABC. And the reason I did that, I went to the larger of the two. Oh, hold on a second. Well, you know, the problem with something like this is we don't really have enough information to know that this is necessarily larger than that. There's not enough information. And we have to assume that these are oriented the same way, so I don't particularly like this example. But we'll do what we can. So we're going to go triangle MLK, even though technically we really don't know if this is smaller than that. We can't assume that it's oriented that way, but in this case I guess we will. MLK. Okay. You use your answer above, list all the pairs of congruent angles. Okay, so congruent angles, we're going to go letter by letter. So angle A is congruent to angle M. Angle B is congruent to angle L. And angle C is congruent to angle K. All right. Using your answer above, write a proportion that relates to corresponding sides which pair similar triangles. Okay, so we have to show all the different angles that the sides where they belong. So the way we're going to do this is simply go around. We're going to go AB and ML. So AB and ML. Oh, why did I do that? Why did I do that? It should be red right there. So blue over red. So we're going to go ML over AB is equal to, and again, now we're going to go LK, which is the last two, and BC, the last two. So LK and BC. LK over BC. And then the last one is going to be MK and AC. And AC, there we go. Okay. Find the value of x. Okay, we're going to say this over that. So mk over AC is going to be equal to ml over AB. There we go. So actually, I guess we'll use this. Why not? So mk is going to be x plus 1 over AC, which is 7, equals 20, which is ml. We're going to use this one over AB, so 20 over 10. Okay, so we're going to make that 2 over 1. X plus 1 over 7 is equal to 2 over 1. Let's cross multiply and solve. So we're going to have x plus 1. That doesn't look great. Hold on. There you go. X plus 1 equals 14. Subtract 1 from both sides. X equals 13. There we go. Okay, not a great example because, again, we don't know this is necessarily smaller than that, but oh well, what can we do? All right, so I think we're near the end here. Yeah, because we're going to ignore that part because we already did dilation. So this is the last page, actually. So I apologize for the length of this video. This is going on for a while. But hey, I figured it'd be worth doing all these in case you want to see these. Okay, so triangle SFG, which is this one here, is similar to triangle STU, which is the larger one. Write a proportion that relates the corresponding sides for each of the similar triangles. Okay, so SF, this one here, right, this one, SF will correspond to ST. We know that because of the letters in the similarity statement. So SF over ST is equal to, now we're going to go FG, which are the last two, and TU, which is the last two. So FG over TU. And then the last part, which is going to be SG, which is the first and last, and then the first and last is SU. But you can physically see it. I mean, you can just visually see where they are there, right? So SG over SU. Okay. All right, that's the proportion. Well, technically it's not really a proportion because it's two equal signs, but whatever. You get the idea. Use your answer from part A to find x. Okay, so we're going to solve for x. Okay, so we're going to use this one and any of the other ones. So SF is going to be 12. ST is going to be 9x minus 9. And we can use either one of these two. We'll use that one. Why not? So FG is 6, and TU is 36. I'm going to simplify that, divide those by 6. We're going to get 12 over 9x minus 9 is equal to 1 over 6. We are then going to cross multiply. So we are going to get 1 times that is going to be 9x minus 9. And then 6 times 12 is 72. We are then going to add 9 to get rid of our constant, plus 9. So we're going to have 9x. Oops. 9x equals 81. Divide by our coefficient, which is 9. And x will equal 9. Okay, that takes care of that. Use your answer from part B to find ST. So ST is this, so we're going to plug in our x value, which is 9. So we're going to say 9x minus 9, and then plug in our 9 value. 9, we do order of operations, 9 times 9 is 81. Subtract 9 from that, you're going to get 72. And there's no unit of measurement, so 72. Last part. Find the scale factor from STU to SFG. So STU is the larger one, so we're going to go larger to big. Alright, so I need to zoom out a little bit so you can see both at the same time. Hold on. I think you can see both there. Okay, so small to big. Small is going to be on, right? STU, no, sorry, I screwed that up. STU is the larger one, so large over small. Okay, so we'll just pick two sides, right? So the large, we'll do TU and FG because they correspond to each other. So 36 over 6. And that's 6 over 1. So the larger triangle is 6 times the size of the smaller triangle. All right, last part. This should look familiar to you. So we have the three similarity reasons. Determine whether or not the triangles are similar. If they are, write a similarity statement and justify by using the postulates. If not, they're not. Okay, so straightforward. So here we have two angles that are congruent to those. Therefore, they are similar because of angle. Straightforward. FGH. So F is 88, U is 88, G is 40, V is 40, and then W would be the last letter. Okay? This one here, they don't give us any angles, but they do give us all the sides, so we're going to have to make a proportion with all three ratios. So let's do this one. So, okay, this is FG, and FG is the bigger one. So FG is that one. FT is this one. So we're going to go blue over red, I guess, yeah. So blue is going to be 63 over, we don't know what that is. We know this is 18, so if we subtract 18 from 63, we'll know what the difference is. So 63 minus 18, so 5, what is it? That's going to be 545, I think. Does that look about right? I think it is. 45 plus 18, carry the 1. Yeah, that's right. Okay. So that's this one. That's that pair. Let's do this pair. So GH and TU. So GH is 70 over, I'm guessing that's 50. And then the last one is going to be FH, which is these two added together. So 65 and 26, add those together, we're going to get 11, carry the 1, 8, 91. So FH is 91, and FU is 65. So we need to see if all three of these ratios are the same. I don't know if they're going to be. Let's find out. I'm going to cheat here. Well, not cheat, but we're going to use a calculator to make our life easier. 63 divided by 45. It's 1 4/10. 70 divided by 50. 1 4/10. Looking good, looking good. And then 91 divided by 65. The 1 4/10. There we go. All right, all right. So those are all the same. Therefore, it's side, side, side. So FGH, we're going to go FTU. Yep, FTU. Boom. Okay. Here we go. Number 24. We're moving right along here. Almost done. So if you've watched this whole thing, gold star for you for sitting through 32 minutes of pure geometry. Kudos. Kudos. Pat yourself on the back. They give us two pairs of sides, and these angles are congruent because they're vertical. So we need to see if these are proportionate. So the smaller one here is 3, the smaller one here is 9. So we're going to go 3 over 9, and we're going to go 5 over 15. And let's see if they're the same ratio, which I believe they are, because look, this is 1/3. This is 1/3. Yes, that does work. So it's side angle side similarity. We're going to go WVU. So WVU. So we started at one that doesn't have a side value. We're going to cross it, and we went across the smaller of the two. This is the smaller of the two, so we need to end up this way. So NMU. That's where people are going to make a mistake, is where they write the similarity statement. So pay attention. Pay close attention to the letters they give you. So they say WVU. So you're going across the line segment where there's no value, because we know we're going to go across NM. But we don't know if we're starting at N or if we're starting at M. What we do know is that they go WVU, so they cross the smaller of the two. So therefore, we have to cross the smaller of the two here, which is why I know we need to go NMU and not MNU. Pay attention to that. That's very, very important. That's an easy way to make a mistake on that. And I bet that's where most people, if they make a mistake, will be there. Okay, last one. Here we go. Again, we're given two pairs of sides and an included angle. So if they are going to be similar, it's going to be because the side angle side. The angles are congruent. Let's see if the sides match up. So the smaller one here, we'll do this one, I guess, on top. I should have done the red and blue. I don't know why I didn't do it before. So red over blue, we're going to go with 22 over 55. And then we're going to go with 25 over 60. Okay. Let's just do this. It's easier. 22 divided by 55. 4/10. 25 divided by 60. Not quite. Not quite. So it's that. All right. So no, not similar. Okay. If you get to this, don't worry about these. We did those before. The dilations used to be part of this unit, but instead we did it during the transformation unit. So guys, if you've stuck through all that, I'm impressed. Honestly, it's a lot of work, and I would love to hear from you. So if you had any issues with these problems, please let me know, and we'll be having our test on Tuesday. All right, see you guys soon.